In this video, we will introduce the vector equation of a line. Let's recall the equation of a line in the Cartesian plane which we are familiar with. In the equation y equals mx plus c, m represents the gradient of the line and c represents the y-intercept. The variables x and y do not take on any fixed values. Rather, the line is the set of points whose x and y coordinates satisfy the equation. For instance, in the equation y equals 2x minus 5, the points whose x and y coordinates satisfy the equation y equals 2x minus 5 form the line. There is another way to describe a line, using vectors. Let's look at an equation like this. Here, r and lambda are not fixed values, but are variables, just like x and y earlier. Lambda is a real number, and r is a position vector. Recall that a position vector of a point is a vector from the origin to the point. Like coordinates, the position vector indicates the point's position from the origin. For different values of lambda, the position vector r will point from the origin to different points in the plane. For instance, when lambda equals 1, r will be the sum of the vectors 2, -1 and 2, 4, giving us the position vector of the point 4, 3. When lambda equals 2, r would be the sum of vectors 2, -1 and 2 times of 2, 4, giving us the position vector of the point 6, 7. In the same manner, when lambda equals 0, r is the position vector of the point 2, -1. When lambda equals -1, r is the position vector of the point 0, -5. When lambda equals half, r is the position vector of the point 3, 1, and so on. Together, these points form a line. Notice that the vector 2, -1 is the position vector of a point that lies on the line, and that the line is parallel to the vector 2, 4. As the vector 2, 4 tells us the direction of the line, we call it the direction vector. We shall now see how to convert a vector equation of a line into a Cartesian equation by first converting it into parametric equations. Let's use the previous vector equation as an example. As the vector r is the position vector of a point on the line, it can also be written as the column vector xy. Simplifying the right-hand side, this gives us two equations, one for the x component and one for the y component. Notice that we have now written x and y in terms of a single variable, lambda. Lambda here is also known as a parameter. Therefore, the equations x equals 2 plus 2 lambda and y equals -1 plus 4 lambda are called the parametric equations of the line. Next, by making lambda the subject of the formula, we obtain two expressions for lambda. Equating the two expressions and rearranging them, we obtain the equation y equals 2x minus 5, the Cartesian equation of the line, and a form that we are familiar with. In summary, the equation of the same straight line can be expressed in three different forms: the vector equation, parametric equations, and the Cartesian equation.